Here is the video solutions for assignment 5 on algebra. On the first page, we have a simple table of additive inverses and multiplicative inverses. Additive inverses, we should know, make 0. So what makes 0 to plus 3? Well, plus 3 minus 3 makes 0, so negative 3 is the additive inverse of positive 3. Negative 7/3 is the additive inverse of positive 7/3. Positive 2x is the additive inverse of negative 2x, and positive 3/4 of x is the additive inverse of negative 3/4 of x. Additive inverses make 0. Multiplicative inverses make 1. So what times 2 makes 1? Well, timesing by a half makes 1. Timesing by 7/3, what do we need to times by 7/3 to make 1? Well, we need to times that by 3/7. Also, you could have written the division equivalents here, so timesing by half is the same as dividing by 2. So that also, in some sense, is the multiplicative inverse, but I prefer the multiplication as the answer. Similarly, timesing by 3/7 is the same as dividing by 7/3. What's the multiplicative inverse of negative 5? Well, what do you have to times by negative 5 to get 1? Well, you have to times it by negative a fifth. Negative a fifth times negative 5 gives you 1. This is the same as dividing by negative 5. And what's the opposite of timesing by a over b? Well, that's timesing by b over a. Because when you do multiply the numerators, multiply the denominators, you get ab over ba, which is ab over ab, which is just 1. This is the same as dividing by a over b. Multiplicative inverses always make 1. Now, a reminder that that 1 is kind of unique in this way because timesing by 1 doesn't do anything. And similarly, adding 0 doesn't do anything. Okay? That's why multiplicative inverses make 1, because then they don't really do anything. Okay, let's move on. So, give an example of an expression that contains exactly 2 terms. These terms are not like terms. So an expression, firstly, does not have an equal sign, and it's just some terms separated by addition signs. Okay? So expressions don't have the equal sign. So we have 1 plus x plus 3xy minus 2 brackets x plus 1y. Okay? So we have 4 terms here. 2 terms. Here we have 4 terms, so I don't know why I've written 4 terms rather than 2 terms. So you just need to write 2 terms apparently. So kind of ignore my answer, but let's go into this in a bit more detail anyway. So if the question was 4 terms, then I'd have been correct. So notice how a term is just a series of factors. In this term here, 3x, y, and z, or 3x, y, z, we have the factors 3, x, y, and z. They make up this term. It's a series of factors. Similarly, this is a term, even though it looks like it's got more than one term, it's just one term, and its factors are negative 2, x plus 1 is a factor, and y is a factor. Okay, so these are terms. Terms are made up of factors. I've circled the 4 terms. Now, I'm an idiot and I haven't answered the question properly, but you get the idea, I hope. Here, this term is made up of the factor x, and this term is just made up of the factor 1. Okay, this one, write an equation with 4 terms. So 2 plus x is equal to y minus 1. There's 4 terms there, fairly straightforward. For this first question, maybe it would have been better just to write 2 of the terms, so 1 plus x would have been fine, or 3x yz plus negative 2 brackets x plus 1y would have also been fine. So either of these answers would have been fine. So this would have been an answer, or this could have been an answer. Okay? Right, next. Let's solve the following equations. So in this question, maybe the best approach is to expand the brackets. So we get 2x minus 6 equals 25. Then we're going to use an additive inverse. We're going to add 6 to both sides. Adding 6 going to give us just 2x on the left-hand side is equal to 31. And then we'll use a multiplicative inverse. We're going to times both sides by half to give us x on the left-hand side is equal to 31 over 2. Good. In the next question here, we'll expand all the brackets again. So 4x minus 16 equals 9x minus 21. Then use an additive inverse, subtract 4x from both sides, giving us no x's minus 16, so negative 16 equals 5x minus 21. And then add 21, use another additive inverse, so 5 is equal to 5x. And then times both sides by a fifth, use a multiplicative inverse, get rid of the 5 times x by timesing it by a fifth, giving us x on the right-hand side is equal to 1. Part 3. Now, my suggested approach in this one is, if we times by 3 on both sides, then we get rid of the thirds. Okay? We can do that to an equation because we can make both sides 3 times bigger, and both sides are still in balance. Okay? So as long as we do the same to both sides, it's okay. So timesing the left-hand side by 3 is just going to give us 2 lots of y minus 4. Timesing the right-hand side by 3 gives us 15 brackets y plus 3. Okay, now we can expand. Expanding the brackets on the left-hand side gives us 2y minus 8. Expanding the right-hand side gives us 15y plus 45. We can use an additive inverse here, subtract 2y from both sides, giving us negative 8 is equal to 13y plus 45. Then use an additive inverse, subtracting the 45 from both sides, giving us negative 53 equals 13y. And then do a multiplicative inverse. We have 13 times y on the right-hand side, so if we times that by a 13th, we're going to get 1y. And that on the left-hand side is negative 53 over 13. Moving on. Okay, so there are a couple approaches to this one. One approach would be to times by 8 on both sides. Timesing on the left-hand side by 8, well, we have an 8th times something. So if we times that by 8, we're using a multiplicative inverse, we just get 1 times. So an 8th times 8 is just 1, so we end up with n plus 6, or 1 times n plus 6, but we don't need the 1 times because 1 times doesn't do anything. On the right-hand side, if we do 8 times 2/5, well, this is the same as doing 8 over 1 times 2/5, which is 16/5. Times by 3n minus 1. So when we times the right-hand side by 8, we get 16/5, brackets 3n minus 1. What can we do now? Well, we don't really like the fifths, so we could now multiply by 5 on both sides to get rid of the fifths. Timesing the left-hand side by 5 gives us 5 brackets n plus 6. Timesing the right-hand side by 5 just gets rid of the fifths. So we get 16 lots of 3n minus 1. Now we have a very nice question. We can just expand the brackets on both sides. Expanding the brackets on the left-hand side gives 5n plus 30. On the right-hand side, we get 48n minus 16. Now we can use additive inverses again. Subtract 5n from both sides, giving us 30 on the left-hand side and 43n minus 16 on the right-hand side. We can then use another additive inverse, add 16 to both sides, giving us 46 on the left-hand side is equal to 43n, because negative 16 plus 16 give us nothing, plus 0. Okay, now use a multiplicative inverse. We have 43 times n on the right-hand side, so to undo 43 times, we're going to need to times by 1 over 43 on both sides. So times by 1 over 43 on the left-hand side gives us 46 over 43. Times by 1 over 43 on the right-hand side gives us just n. So we have n is equal to 46 over 43, which is the final answer. Let's move on. Okay, so here we have an equation with a squared term. Okay, so the first thing to do is to get x squared on its own. So let's use additive inverse. Let's subtract 5 from both sides, giving us x squared is equal to 49. Now we can take the square root. So if we take the square root of the left-hand side, we just get x. But on the right-hand side, we're going to get 2 answers. We're going to get 7 or minus 7, because 7 squared is 49, and negative 7 times negative 7 is also 49, so there must be 2 answers. You could also write this as plus minus 7. So that means, that symbol plus minus means plus 7 or minus 7. Okay, 3x squared minus 11 is equal to 37. So if we add 11 to both sides, we get 3x squared equals 48. Now we can divide both sides by 3 to get x squared on its own, or times both sides by a third, rather, giving us 16. Now we take the square root. So if we square root x squared, we're going to get x, and then we're going to take the square root of 16, which will give us two answers, 4 or negative 4. Okay. So it's worth noting that at this stage, some people might think about taking the square root. But if you take the square root of 3x squared, it's not got an answer. You can't do anything to the square root of 3x squared. You can only do something to the square root of x squared, because the square root of x squared is x. The square root of 3x squared, it's not possible to do that. There's not an obvious answer. So that's why you have to get x squared on its own before you can take the square root. Okay, let's move on. So James and Joyce are given this equation. James claims that x is 2 satisfies the equation. Joyce claims that x is negative 2 satisfies the equation. Who is correct? Convince me. So this is a question about substitution. Okay. So to show something satisfies an equation, you substitute it into the equation. So for James, let's substitute in 2. So 3 brackets 2 squared plus 1. Is this the same as 12 brackets 2 minus 11? Well, let's simplify the left-hand side. 2 squared is 4, so it's 3 times 4, which is 12. Add the 1. And then the right-hand side becomes 24, subtract 11. So 12 plus 1 is 13. 24 minus 11 is 13. So James is correct. 2 does satisfy the equation. If we move on, let's look at Joyce's suggestion. So Joyce claims that negative 2 satisfies the equation, so let's substitute it in. So notice how I'm using brackets to substitute. When we have these brackets, it makes the negative symbol clear in the order of operations. So here we do negative 2 squared, so negative 2 times negative 2, and then we multiply it by 3. If you don't have the brackets, it's not clear what you're squaring. Here it's very clear I'm squaring negative 2, which means it's negative 2 times negative 2. So negative 2 times negative 2 is 4. 4 times 3 is 12, so it's 12 plus 1. 12 times negative 2 is negative 24, subtract 11. 12 plus 1 is 13. Negative 24 subtract 11 is negative 35. So these are not the same, so negative 2 does not satisfy the equation. So actually James is correct, and he's the only one that's correct. Okay, let's move on to question 7. In question 7, we're asked to make x the subject, or 7 part 1 at least. So let's subtract 2y from both sides to get 5x is equal to 13, subtract 2y, then times both sides by a fifth to give us x on the left-hand side is equal to a fifth of 13 minus 2y. One way of writing it. Another way of writing the same thing is to say, well, it's 13 over 5 minus 2y over 5. Another way of writing it would be x is equal to 13 minus 2y all over 5. These answers are all correct. Okay. For this question, we're going to make h the subject. The first thing we might do is subtract 2r squared from both sides using an additive inverse. From here, we're going to use a multiplicative inverse. The quickest way to do it is to times both sides by 1 over 5r. If we times each term on the left-hand side by 1 over 5r, we get a over 5r minus 2r squared over 5r. And this is just equal to h. So this answer is correct. H is the subject. Done. We could have written this as a minus 2r squared all over 5r, same thing. Now, one thing to note is that since, if I rewrite 2r squared as 2 times r over 5 times r, notice how the r's, one of the factors of r can cancel. And so if we wanted to, we could simplify this to a over 5r minus 2r over 5. Now, this wasn't necessary, but it's just useful to see that we could have simplified the answer slightly if we wanted to. Okay, so that's that question done. Also, some people, instead of timesing by 1 over 5r in one go, would have maybe thought about timesing by 1 over 5 and then timesing by 1 over r in 2 stages. I think it's better to do it in one go because it's less confusing. Okay, making y the subject in this question. Now, this is difficult. The question is designed to remind you that y being the subject means it cannot be on both sides of the equation. So it can only be on one side of the equation. So let's expand the brackets first. So you have 7y minus 7x equals 2y minus 8. Okay. Now y is on both sides right now. So what I'm going to do is get the y's on one side. So to do that, I'll subtract 2y from both sides. So now y is only on one side, so it's going to make our lives much easier. From here, let's add 7x. And then finally, use a multiplicative inverse, timesing by a fifth on both sides, giving us y is equal to 7x subtract 8 over 5, or 7x over 5 minus 8 over 5. Or you could write a fifth bracket, 7x minus 8, or the example I said at the start, 7x minus 8 all over 5. Either of those would have been correct. Oops, let's go back. Looks like I didn't do this question, so let's do it now. Make C the subject. So the first thing you might do is use a multiplicative inverse. The quickest way to do it is to times by 1 over 2m on both sides, because then we just get c squared on its own. So we get 3e over 2m equals c squared. Now to get c the subject, we're going to take the square root of both sides. I'm going to do this in painful detail. Equals the square root of c squared. Now notice how I've done the square root symbol over the whole fraction. And then finally, I just simplify the right-hand side to get that. So c is equal to the square root of 3e over 2m. Okay, let's move on. So this question set up the equation. We know the perimeters are the same. We know it's a heptagon, so there are 5 sides of 3x minus 2, which is the same as 7 sides of 2x minus a half. From here we can expand to get 15x minus 10 equals 14x minus 7 over 2, or 3.5. Subtracting 14x just gives us x minus 10 on the left-hand side. It's equal to negative 7 over 2 on the right-hand side. Adding 10 gives us x equals 10, subtract 7 over 2. Now, it's probably easiest to think about this as decimals because 0.5s are quite nice. So, but let's look at its fraction first. So to do addition of fractions, we're going to need to make them all halves. So this is 20 halves, subtract 7 halves, because 10 is the same as 20 over 2, which is going to give us 13 halves. But, as I said, a better way is probably to do decimals. 10 minus 3.5 gives us 6.5. So 6.5 is the value of x. Now it says work out the side length of each shape. So we know for the pentagon that the side length is 3x minus 2. We know what x is, so we just substitute 6.5 in. 3 lots of 6.5, subtract 2, is going to give us 3 times 6.5 is 19.5 minus 2, which is 17.5. For the heptagon, 2x minus half, well, 2 times 6.5 subtract half. It's going to give us 12.5 overall. Okay. So if we really wanted to, we could check that these answers were correct. If we times one side length by 5, from the pentagon we get 87.5 as the perimeter. If we times 12.5 by 7, we're going to get 87.5 as well. So this shows that the perimeters are the same. This is a nice check that you can do. Okay, question 9 here. It says, write the next line. So the next line says subtract 4. So we do 2 brackets x plus 4, subtract 4. We've subtracted 4 from the left-hand side. And if we subtract 4 from the right-hand side, we just get this. Okay, nothing else. There's no other option. This is the only answer you could have written. Okay, a way to think about this is 2 brackets x, a common mistake rather, is to write this as the answer. Trying to subtract 4 inside the bracket, that's not allowed, you can't do that. That's wrong. That cross means it's wrong. Another way that people made mistakes is to subtract 4 from the coefficient of the brackets somehow magically to get this. This is also wrong, but it was a common answer. Okay. The reason it's wrong is because we could draw the left-hand side as 2 lots of x plus 4. Like literally, there are 2 x plus 4s there. This is the same as 3 2x plus 7s. Okay. How can I take away 4 from this? Like, you can't take away 4. You can't get inside any of these boxes. Okay, so the only thing you can do is just put a negative 4 outside the boxes. Okay. Part 3, I'll do part 3 first because it's on the page. So, times by 4/3. Well, timesing by 4/3 with 3/4, we just get times 1, so it doesn't change anything. So we could have just written that, I suppose, and then 4/3 times bracket 6x minus 5. But a better answer is probably just x plus 4 is equal to 4/3 of 6x minus 5. Now, you may have written x plus 4 is equal to 24x over 3 minus 20 over 3. That would have also been fine. Okay, so that was the answer there. Moving on. In this question, it says expand the brackets. Now, notice how we have negative 2 lots of x plus 4. So we're going to have to do negative 2 times x and negative 2 times 4, giving us 3x minus 2x. And then minus the 8. A common mistake was not to put negative 8 there. Here we have a half lots of 2x, which is x, and then a half lots of 7, which is 7 over 2, plus 3. Over here, part 4, we have to take the square root of t squared, which is just t. And then the square root of the right-hand side, where you can't square root terms. You can only square root sides. So it's just square root of the whole thing. You can't do anything else. It is not the same as 3 plus 2k, which is a common mistake. Now, a good way to see that this is, you can't square root terms is, well, we know that 5 squared is 3 squared plus 4 squared. You can check that 25 is the same as 9 plus 16. But the square root of 5 squared, which is 5, is not the same as square rooting the terms. This would suggest, if it were true, that 5 would be the same as 3 plus 4, if we were allowed to just square root each term separately. But we're not. We can't do anything to that. So we can't have the last line there. It doesn't make sense. 5 is not the same as 3 plus 4, so we can't square root terms. We can only square root a side. So the penultimate line here, this line here, is correct. That's allowed, but the next line doesn't follow. Okay, let's do the final question now. Okay, in this question, we need to remember that vertically opposite angles are equal. So we can say that 7f plus 5 is the same as 2f plus 35. This is a simple equation to solve. We can subtract 2f from both sides, and then subtract 5 from both sides, giving us f is equal to 6. This, if f is 6, that means that this angle here is 47 degrees. These two angles lie on a straight line, so this means that the blue angle I've just highlighted is 180 subtract 47, which is 133. So that means that 5g plus 18 is 133 degrees. This is an easy equation to solve. 5g is equal to 115, subtracting 18 from both sides. Timesing both sides by a fifth gives us g is equal to 23. So we have now found the values of f and g. They are 6 and 23 respectively.